Okay, let's unpack this. We are diving deep today into a corner of the AI world that is moving incredibly fast. Large language models specifically trained to write code.
Yeah, it's a space that's just buzzing right now.
Absolutely. And we've got a stack of sources right here detailing the current state of play. And, well, they seem to point towards a pretty clear frontrunner for 2025.
Mm.
So our mission in this deep dive is to figure out exactly why one particular model is being called the champion code LLM, and what that really means for you, whether you're neck deep in software development or maybe just curious about how AI is changing things.
Right.
We're going to look at the evidence presented, the comparisons made in the sources, and the reported real-world impact.
And I think what's fascinating here is framing this not just as like a technical spec sheet review,
Yeah.
but really understanding the practical implications. What truly distinguishes the best from the rest when the rubber actually hits the road in software development? We'll dig into the benchmark data the sources cite for sure, but also that lived experience that's being reported.
Absolutely. So let's jump straight into the headline from the source material. Claude 4, it's currently being ranked as the best LLM for code.
That's the big claim. And they back it up with some pretty compelling numbers.
They do. Like what?
When you look at the SWE-bench leaderboard, that's a benchmark specifically designed to test these models on, realistic software engineering tasks.
Right.
Claude 4 Opus hits an impressive 79.4% when it's allowed to think in parallel. And its sibling, Sonnet, actually scores slightly higher at 80.2% in that parallel testing.
Wow. Okay. 80%.
Yeah, and the source to emphasize this places both models squarely ahead of, well, every rival on the leaderboards right now.
And the sources aren't shy about the significance of that, are they?
Not at all. They point out that while benchmarks aren't the entire story, seeing a model score like 30 points higher than previous champions,
Right.
they describe that as seismic.
Seismic. That's a strong word. It signals a fundamental shift in capability.
Exactly. The analysis in the sources is basically that this moves these models from feeling like glorified autocomplete toys to functioning more like capable junior developers. Developers who, simply don't get tired or forget details across huge amounts of code. That 30-point jump, they argue, that's the line being crossed into a whole new level of utility.
Okay, so if we were to line up the top code LLMs, sort of like different types of cars, like the source describes, each with its own strengths and quirks, what does that lineup look like?
That's actually a great way to think about it. The source provides a pretty clear comparison of the key players.
Okay, let's run through them then.
All right. First, as we mentioned, is Claude Opus 4. The sources highlight its strong SWE-bench, scores 72.5% standard, 79.4% parallel, and solid terminal bench results too. That's the test for using tools like Bash.
Got it. Terminal-bench.
Yeah, 43.2% standard, 50.0% parallel. Its sweet spot, according to the analysis, is these marathon refactors, long, complex tasks.
Okay, the endurance runner.
Exactly. The main quirk noted, though, is its higher token cost. It's more expensive to run.
Right. Makes sense for the heavy lifter. What about its sibling Sonnet?
So Claude Sonnet 4. The sources show it with slightly stronger SWE-bench numbers, actually 72.7% standard, 80.2% parallel.
Oh, interesting. Higher than Opus.
On SWE-bench, yeah.
Yeah.
Although its terminal bench is a bit lower, 35.5% standard, 41.3% parallel, its sweet spot is identified as quick edits and tests.
So faster, more agile stuff.
Exactly. The quirk here, though, is that the sources report it can sometimes struggle on really huge projects, like those over 100,000 tokens of context.
Ah, okay, so there's a scale limitation there potentially. Who else is in this lineup according to the sources?
Next up is Gemini 2.5 Pro. The source describes it as solid sedan. It has decent SW bench scores, around 63.2%, but a notably lower terminal bench at 25.3%.
Okay.
Its sweet spot is presented as things like data science demos, multimodal tasks. But the significant quirk the source points out, it apparently hallucinates on diffs.
Ooh, hallucinating code changes.
Yeah, that sounds like a potential deal breaker for, critical tasks.
Definitely a major problem for reliable code generation, they say.
Mm.
Then you have OpenAI O3, which the source calls the versatile Coupe.
Okay.
It shows good SW bench scores, 69.1%, and decent terminal bench, 30.2%. Its strength is apparently its versatile toolchain.
But there's a quirk.
Yes. The primary quirk highlighted is that its context fades after 20K tokens.
So it starts to forget things on longer tasks.
Seems like it makes it less reliable for those long, deep code sessions compared to, say, Opus.
Right. Memory limitations on larger code bases over time are an issue there.
Yeah.
And finally,
GPT 4.1 described as the vintage roadster. It has the lowest SWE-bench score among this group, 54.6%, but a decent terminal bench at 30.3%.
And its sweet spot, natural language tasks mainly. The quirks are that the sources say it lags on software tasks compared to the others and makes brittle suggestions.
Brittle suggestions, meaning they might break easily.
Yeah, suggestions that might break things or just aren't very robust. Not ideal for production code.
All right, so based on this overview from the sources, it really does seem like the Claude 4 models, Opus and Sonnet, are positioned ahead for these core software engineering tasks.
That's the picture they paint.
So let's dive a bit deeper into those two siblings then, the endurance champion and the agile sprinter. How does the source elaborate on their distinct capabilities?
They really lean into that athlete analogy. It's quite effective. Opus 4 is the endurance champion, like a Tour de France winner.
Okay.
The source says it excels at these long, gnarly sessions. What that means in practice, they report, is it keeps literally thousands of tokens of context straight for hours.
Hours. That's impressive.
Yeah. It handles Everest-level refactors across huge code bases, can juggle dozens of files simultaneously, run CI checks in parallel using tools, and importantly, it remembers decisions made hours ago in a complex task.
Everest-level refactors and maintaining state for hours. I mean, that does sound like a significant leap beyond previous models that might lose track pretty quickly.
It really is framed that way. The source specifically calls it ideal for tasks like refactoring a legacy codebase while you sleep in some automated workflow.
Wow.
The trade-off, though, for all that power and memory, they point out, is the cost.
Right. Always a trade-off. And Sonnet, the agile sprinter, what's its superpower based on the sources?
Sonnet is all about pure sprint speed. The sources say it hits requests in under a second.
Under a second. Okay.
Making it perfect for those quick, focused tasks. Test generation, docstring polishing, or one-off code reviews. Things like that. And while it might not have Opus's marathon stamina for those multi-hour tasks across vast contexts, the sources report it still nails subtle reasoning tasks, particularly when the context stays under roughly, say, 40,000 tokens. They note it handles full RFCs in testing, which is quite a lot.
Okay, so still very capable, just maybe not for those absolute marathon sessions. And the cost difference is a major factor in how you might use them, right?
Oh, absolutely crucial. Sonnet is, according to the sources, about 1/5 the price of Opus.
1/5? That's significant.
Huge difference. They frame Sonnet as the pragmatic choice for cost-conscious teams who still need top-tier edits on a daily basis for the smaller, faster tasks.
So they share a common core intelligence, essentially, but one is built for depth and duration, the expensive one.
Right, Opus.
While the other, Sonnet, is optimized for speed and cost-effectiveness on more focused problems. Kind of like using, a bulldozer for a foundation and then a smaller excavator for digging a trench.
That's a perfect analogy, precisely. The source highlights this flexibility. You can use Sonnet as your daily driver, right? For chat-style coding help, quick fixes. And then reserve Opus for those scheduled heavy lifts that need immense context and persistence. Maybe run those overnight in automated pipelines because the cost is justified by how complex the task is.
And they gave cost examples?
Yeah, like $1.80 for a complex multi-step Opus run versus just $0.15 for a similar Sonnet run in their tests. Big difference.
Okay, benchmarks provide important data points, but where it gets really interesting for me is the lived experience. The source includes this field report from spending a weekend putting Claude 4 through its paces inside Zed, that code editor. What did that show?
Yeah, this section really brings the model's abilities to life. The report details several examples that are pretty compelling.
Like what?
Well, one was a 0 to UI in one prompt using Sonnet. The user asked it to basically scaffold a responsive Next.js navbar component.
Okay, a common task.
A very common task.
Yeah.
And the source reports it produced production-grade code, including things like ARIA labels for accessibility, dark mode classes, proper stuff.
Things a human developer would need to add.
Exactly. And it apparently saved the developer a full hour of manual work on that component.
An hour saved on one prompt for a standard UI pattern. I mean, that is tangible value the source is highlighting right there.
It really is. Another striking example was described as a 7-hour autonomy session, this time with Opus.
7 hours? Doing what?
It refactored an open-source Rust plugin. The sources report the model is able to inspect upstream Rust crates, Those are like code libraries in Rust.
Right, dependencies.
Insert helper methods where needed, and even run cargo clippy, that's a Rust linter, and code formatter run it until everything was clean and passed all the checks.
Wow, autonomously.
That's what they report. And the key takeaway from this marathon session: no hallucinated imports, no broken build, just clean working code.
That's huge.
Yeah. For deep refactors like that, the source flat out states Opus is best Elm for code by a city block.
By a city block? Okay. That's strong, specific praise from the source's perspective. What about the quality of the output beyond just the code itself, like explanations?
Good question. The report also noted human quality explanations in the commit messages generated by Claude 4.
Oh, interesting.
They were described as concise, specific, and free of boilerplate, exactly what you'd hope for from a thoughtful human contributor explaining their changes, not just generic AI waffle.
That's actually really important for team collaboration. So the overall result from that weekend of testing, according to the source, what was the bottom line?
Simply put, Claude 4 wiped out half the usual toil while raising quality.
Okay, less work and better results.
Exactly. That powerful combination, reducing effort and increasing quality simultaneously, is presented as why the sources position it decisively atop the best SELM for code leaderboard for practical engineering.
But, even the best tools need a skilled operator. The sources spend some time talking about prompt engineering that actually matters. How do you effectively steer these models to get those kinds of results?
Right, that's crucial. The sources are very clear. Models do what you ask, not what you meant.
Classic programming problem, just with natural language now.
Precisely. Crafting effective prompts is presented as absolutely crucial to unlocking their potential. They provide concrete examples for what they call their prompt playbook.
Okay, do they offer any specific examples or, recipes for prompts that work well?
Absolutely. For a Sonnet UI sprint, like that navbar example, the template they describe emphasizes setting a clear goal. Using bullet criteria for clarity on requirements like must be responsive, use Tailwind CSS, etc. And importantly, adding a line to force a dis-style response. Return only changed files.
Ah, that return only changed files line. That sounds incredibly practical for a developer workflow. Just give me the changes.
Exactly. It ensures the output is clean and easy to apply directly into your project without wading through unchanged code.
Smart. What about for Opus? For those marathon tasks?
For an Opus marathon refactor, the template uses explicit context to ground the model in the project state, a clear task description, and breaks down the work into numbered steps, like a checklist.
Okay.
The source explains that Opus follows this checklist, first producing a plan, then executing it step by step. And because of its long memory, that persistence we talked about, you can easily chain follow-ups without having to re-explain the entire project context from scratch.
Ah, so like telling it to add caching after it's done refactoring the core logic, and it just remembers the original goal and context.
Exactly that. It maintains the state of the conversation and the task. They also mentioned a specific instruction for tool use, which sounded quite powerful.
Oh, yeah.
Adding this line: when separate operations are independent, call all required tools in parallel.
Okay, so telling it to multitask when possible.
Right. Adding that single line to prompts reportedly bumps tool use success toward 100%, which is a huge deal for complex tasks involving running tests, linters, or other command line tools reliably.
Wow, okay. These prompt patterns seem key then to transforming these models from just assistants into really powerful coworkers.
That's the idea presented.
Now, let's talk about what the sources call the headline upgrade, this idea of extended thinking. How does this turn the model into a background coworker, as the sources suggest?
This feature is described as fundamentally shifting Claude 4 from being just a conversational chatbot to something that can autonomously work on complex problems in the background over time.
Okay.
The sources provide some really compelling comparisons, contrasting typical human developer behavior on tough tasks with how Opus behaves with this extended thinking enabled.
Okay, lay out those comparisons for us. That sounds interesting.
All right, so for a multi-file refactor, a human developer, has to juggle understanding multiple files, multiple contexts simultaneously.
Yeah, easy to miss something.
Right, often forgetting a small detail or a corner case. Opus, with extended thinking, is described as first streaming a step-by-step plan, then editing, say, 40 files, and importantly, citing every single change in a diff output, automatically.
That sounds dramatically more reliable and thorough than relying purely on, like, huge short-term memory across a large code base.
It certainly seems designed to address those exact human limitations.
Mm-hmm.
Or for a data crunching script, a human might bounce between a Python shell, documentation, search engines, and as the source puts it, kind of pre-pandas behaves
Yeah,
correctly.
same there.
We all have. Opus, instead, is described as writing the script itself, running it in Anthropic's isolated sandbox environment.
Running it.
Yeah,
Oh.
running the code, and then
Mhm.
just returning the final output, like the CSV file you asked for.
Running the code itself in a sandbox. That
Yeah.
adds a whole other layer of capability beyond just generating the code text. That's significant.
Absolutely. And one more, a marathon bug hunt, where a human developer might spend hours reproducing the bug, forming hypotheses, trying patches, rerunning tests, taking breaks, getting coffee.
The usual grind.
Right. Opus is described as just spinning for hours if needed, calling tests in parallel autonomously, and logging each decision it makes during the whole debugging process.
Wow. The source has really emphasized that this relentlessly persistent nature is a key reason Opus tops leaderboards specifically for practical engineering tasks. It just doesn't get distracted or tired in the same way a human does over hours of focused, complex work.
That persistence, combined with its huge context window, is presented as a fundamental change in how these tools can tackle large, difficult software problems.
Okay, so for teams already using maybe older models, the idea of migrating might seem a bit daunting. Does the source offer a practical, maybe an easy path to upgrade?
Yes, they do. They describe what they call a friction-free upgrade path. Sound
Yeah.
appealing.
Friction-free, I like the sound of that. How does that work according to their playbook?
Okay, step one. Start with Sonnet in shadow mode.
Shadow mode.
Yeah, you basically mirror your existing LLM calls to Sonnet, log the differences in responses side by side, but you don't use Sonnet's output in production yet.
Ah, so you can compare its answers to your current model on real tasks without any risk.
Exactly. It gives you instant insight into how it performs on your actual real-world prompts without any risk to your live systems. You gather data risk-free.
Smart. Okay, step two.
Step two, use explicit instruction framing. So instead of maybe vague prompts you might have used with older models like optimize this function,
Uh-huh.
you get really specific like rewrite optimize search to O(n log n complexity and include unit tests covering edge cases.
The sources note that Claude's tighter instruction following means you can demand much more precise, predictable outcomes.
Right. More like giving clear, actionable requirements to a capable colleague rather than just hinting.
Exactly. And step three, incremental rollout. Don't switch everything at once. Start with low-risk tasks.
Things like generating doc strings, adding type hints, fixing automated linter warnings tasks, where mistakes are cheap and really easy to catch before you deploy it to assist with critical services or complex business logic.
That makes sense. Baby steps. And what kind of outcomes should teams expect if they follow this path, according to the source? What's the payoff?
The report suggests that within about a week, you should start seeing why the shift is happening. The code diff noise drops, meaning the changes the model produces are cleaner, more focused, easier for humans to review.
Less junk to sift through.
Right. Test coverage climbs as the model helps fill in the gaps, and reviewers start approving pull requests faster, often after one pass instead of three.
Okay, that sounds like significant, tangible improvements across the entire software development lifecycle. Faster reviews, better coverage, cleaner code.
That's the promise outlined.
The sources also included a sort of prompt cheat sheet or quick guide for different phases of development, right? Showing how to use Sonnet versus Opus.
They did, yeah. Showing how you might leverage them differently, depending on the task. First, starting a greenfield prototype, for instance.
Yeah.
Sonnet might be used to quickly generate a minimal Flask API, just to get something running fast, get the basics up.
Right. Quick scaffolding.
While Opus could handle designing the whole microservice architecture, including the API specs, the Docker files, maybe even the database schemas, the bigger picture design.
Okay. Using Sonnet for rapid scaffolding, Opus for deeper architectural design. Makes sense. What about testing?
For writing unit tests, Sonnet could write tests for specific files or functions you pointed at, quick, targeted tests, whereas Opus could be used to expand the test suite much more broadly, aiming for higher coverage, maybe even adding more advanced property-based tests, which explore a wider range of inputs automatically.
So Sonnet for targeted testing, Opus for broader, more robust coverage.
Got it.
Performance.
In performance tuning, Sonnet might suggest quick fixes for a known bottleneck function you've identified. But Opus could handle rewriting an entire algorithm to improve its fundamental complexity, like changing an ON2 algorithm to ON log n, and
Yep.
then benchmarking the result, maybe even generating a graph showing the speed up.
Wow. So Sonnet for tactical suggestions, Opus for fundamental changes, and the analysis to back it up.
Exactly. And one more they mention, security pass. Sonnet could scan code for common pitfalls, like SQL injection vulnerabilities and suggest fixes.
Useful.
But Opus could perform a full threat model review of an entire system and output a detailed risk matrix CSV based on analyzing the code and architecture. Much deeper analysis.
Notice again how the Opus prompts described in the sources often require that longer context and leverage those tool calls because the tasks are just deeper, right?
Right. It's really designed to lean into its strengths for those deep, multifaceted analysis and execution tasks, just like the sources pointed out earlier.
So revisiting the rivals one last time based on this source material, where do they stand now compared to Claude 4? What's the final assessment?
Well, the sources are pretty direct in their assessment here. While models like Gemini, OpenAI's O3, and older GPT models definitely made significant inroads earlier,
Sure.
the analysis concludes that right now Claude 4 holds the high ground for code tasks. It's specifically cited for its marathon reasoning, human-like prose, rock-solid diffs.
And the rivals?
The sources reiterate those specific weaknesses we touched on: Gemini's tendency to hallucinate diffs, O3's context fading after 20K tokens, and GPT 4.1 just generally lagging on core software tasks and making those brittle suggestions.
So aside from maybe the consideration of Opus's cost on really huge continuous runs,
Right, that's the trade-off.
the sources really seem to paint Claude 4 as the clear leader if your primary metric is just shipping software faster.
They absolutely do. The analysis suggests that all roads lead to Claude if that's your main goal, and they point to both the latest benchmark data and the reported sentiment from the developer community, places like Reddit, Hacker News, as backing up this claim. The phrases Claude 4 and Best Elm for Code are presented as practically synonymous right now, at least within the context of these sources.
This level of capability, though, it goes beyond just writing functions faster, doesn't it? What kind of new use cases or entirely new scenarios do models like Claude 4 unlock that weren't really practical before, based on what the sources are saying?
Yeah, this is where the discussion in the sources gets really interesting about the future possibilities. They talk about things like implementing living style guides.
Living style guides, what's that?
Imagine a bot watching pull requests in real time, automatically rewriting non-idiomatic code based on your team's established standards, and even linking directly to the relevant documentation explaining why the change was made.
Wow, that would free up human reviewers from so many tedious nitpicks. A massive time saver and consistency booster for engineering teams.
Exactly. Or how about zero-day mitigation?
Okay.
The source proposes feeding real-time security vulnerability feeds, CVEs, directly into Opus, allowing it to scan your entire codebase fleet for vulnerable patterns.
Across all your projects.
Yeah, draft potential patches and stage them for human review, potentially before the workday even begins in your time zone.
Proactive, automated security scanning and patching at scale. I mean, that's a powerful and potentially company-saving capability right there.
A big vision. And the sources also revisit that concept of the one-person SaaS startup scenario that's been kicked around in the tech world.
The unicorn solopreneur.
Right. With Sonnet as your daily coding assistant handling the quick tasks, and Opus acting as an overnight feature factory, tackling large, complex features autonomously while you sleep. That vision of a $1 billion company, single employee, starts to look significantly more plausible, according to this analysis.
And I guess the implication is all of these advanced use cases, based on the source material, they require an AI engine that is, as they put it, indisputably the best elm for code. You need that top-tier reliability and capability.
Exactly. The level of reliability, the deep context understanding, and that relentless persistence needed for those kinds of truly transformative tasks, it points directly back to the capabilities the sources are attributing specifically to Claude 4 right now.
Okay, before we wrap up, the source included a quick FAQ section addressing some common questions. Let's hit those points rapidly. First, does Sonnet really hit that 20,000 token context wall like some older models we discussed?
No, not according to the source's testing. They reported it successfully handled full RFC documents, which are actually around 40,000 tokens, and it did so with accurate citations. Opus, of course, goes even further with its extended thinking capabilities.
Good to clarify. What about the big concern, proprietary code snippets leaking into the model's training data? That's always a worry for companies.
Yeah, valid concern.
Yeah.
The sources mention Anthropic's stated policy explicitly forbidding training on customer prompts. But, they add, if you're still particularly concerned about keeping everything strictly internal, the sources suggest self-hosting the model via services like Amazon Bedrock as an option. Gives you maximum control.
Right, for the truly paranoid or regulated industries. And specifically for Rust developers out there, which model is performing best according to the source's testing?
That would be Opus, by a healthy margin, apparently. The sources report that Cargo checks those automated checks for Rust code quality and correctness pass on the first try about 88% of the time in their tests using Opus.
88% first try, that's pretty good.
Yeah, they call that miles ahead of models like GPT-4.1 in their specific Rust tests.
Okay, so to synthesize the core takeaways from all this source material we've covered, Claude 4 delivers, quote, quality without drag.
Right, meaning it completes and polishes tasks reliably, actually finishing what other models might start but then fail to perfect or get right.
It provides context that sticks.
Yeah, architectural decisions or subtle details discussed way early in a long session are actually remembered and factored into suggestions hours or maybe even days later within a continuous task using that extended thinking.
And maybe just as importantly, it has a voice you can put in a PR description.
Its generated explanations for the code changes it makes are clear, specific, and sound like a competent human contributor would write them, which really eases the review process for the rest of the team.
So stacking all that together, it becomes pretty clear why the sources conclude that this combination, the reliability, the deep context, the quality of the output, is why Claude 4 is currently being considered the best LLM for code.
Yeah.
It's framed as fundamentally changing how teams can approach software development by tackling a lot of that common toil and simultaneously raising the bar for code quality.
It's a powerful blend of capability and practical utility that the sources really highlight throughout their analysis.
So for you listening, maybe take a moment to think about this, based only on what the sources have shared today. What is the potential impact on your daily work or your team's work of having a background coworker that is relentlessly persistent? Capable of spinning for hours on a single tricky bug hunt or a multi-file refactor without getting tired or distracted. Or looking bigger picture, what could that $1 billion company, single employee scenario the sources mention really look like with this kind of technology acting as your tireless assistant? How does this potentially change the fundamental nature of being a developer?
These are pretty significant questions raised by the capabilities the sources describe, for sure.
Definitely something to mull over as you consider these new tools and their implications. That's all for this deep dive.